Yeah, in the security group.
So security group I've gone to. So here you are saying create security group, and you also found launch wizard.
Yeah, launch wizard. Yes, over there. Like you can see the Sydney SG and default and down. I'm getting two, like launch wizard, two of them. So I deleted two of them morning, and again afternoon I got one more like one thing again like launch wizard, and I deleted that too. Now it's clear.
Maybe while some more launch wizard. Okay, let me try like this. Okay, I got something into my mind. I think you have, while creating an instance, you might have taken a security group created separately and attached with that, like this, right? The security group with launch wizard -1 or something like that. Alright? The one which you have
Uh,
deleted.
I can't see anything sir in your screen.
You can't see my screen.
I mean, I can't see the launch wizard. It's normal screen. I can see it, but it's normal screen.
This is where I'm talking. The highlight one,
Your
security.
cursor was only, no, I can't see the highlight one. Your cursor is stuck at the action place.
Okay. So now,
It's still there, sir. Yeah, now it's okay.
now it's okay, right? So I think
Yeah,
this is what I think you have deleted the launch wizard one. Okay, so while creating an instance, you probably have taken a new security group created, I guess.
okay,
So that's why it has created a new security groups with the name launch wizard.
okay,
Okay, so that's not an issue. You
okay,
can have any number of security groups, and that won't be. They are not charged by you. Okay,
okay,
so not
okay,
to
sir.
worry. But if you feel that you don't want anything, you can delete them. But please don't try to delete default VPCs.
Okay,
Okay. Security groups you can just do, but default security group it will not allow you to do. You cannot delete default security groups also. But try, not an issue. Okay,
thank
fine.
you, sir.
So today's agenda, let's start. Okay, is there any other doubt you wanted to discuss, or shall we jump into our today's class? How
We
many
can go to the class, sir.
yes, fine. Let me just check how many have joined into the class for today. Sai is there, Shilpa, Vaishnavi, Rajita is there, Prashant, Chandra, Anu. Hi, Prashant, what about Usman? Is he having any issue?
I
Or?
don't know. I think he is a problem in power, sir. There is a
Okay,
problem.
so he's having some issues with that. I think probably
Mm.
for past 3 days he's having that issue. Fine, not an issue. You just help him with the topics and ask him to whenever he just joined to the class, let him clarify all his doubts. Okay, now my question is, okay, one last question. Let me ask you about the previous classes and then start with our today's class. What for the snapshot? How can we use the snapshots? What is the purpose of taking snapshots?
Backup of our data and also to extend our space in the
That's fine.
drivers.
Good answer. It is a backup of our data so that we can just, whenever we lost or there is something wrong happens with the, current volume, we can create any number of volumes with that. That's fine. And we can also extend whenever we wanted. The current volume to be extended, we can extend that using this. Any other use? Any other? Yes. Can we? Okay, now you have an instance created in Sydney region. Now since we are currently in Sydney region, so you have created an instance in Sydney region, and there is a volume attached to it, to that instance, and there is some data you have entered or copied into that or uploaded. Then all of a sudden, okay, your client who is sitting in US wanted to access that data and with less latency. So what you have decided is to create another server and provide this data in US region. So can we do it? Is there any chance that it is possible to copy all this data of this instance and that particular volume which is attached to that instance in Sydney region to US region?
Yes, sir.
Yes.
Yes, sir. There is a chance we can copy.
How is that possible? It's quite simple, right? You take the snapshot of the volume, okay? That volume you copy into the other region, whichever the region you wanted, that snapshot. Then from that snapshot you create a volume, fine, we'll get the volume and the data available. So that is the purpose. You can also, access your data across the regions by taking the snapshot. Someone else is joining. Okay. So now, okay, let's begin like this. For example, have you anybody heard anything about crashing the servers, that due to huge requests the servers have gone crashed? Have you heard anything about that? Especially e-commerce sites and the government sites servers.
Yeah, like we say the server is low, the server is down,
Yeah, the
like
service
that.
is down, the sites are not reachable.
Yeah.
Do
Yes,
you know
sir. When
why?
you are going to check the results, then
Exactly, exactly. So, when you are trying to check the results, everybody, try checking their results at the same time. So they load, okay, the number of requests hitting to that website increases enormously, n number of more than our expectations, and automatically, such a huge load when hits to this website, the server on which the website is built will not be able to bear such a huge load, and then it will just go crash by itself. So that is what happens. Now what do we do in order to come out of that? How do we safeguard our environment, and how do we provide the need to the people? How do we serve all those requests hitting to our website? How is that possible? Okay, for example, you have four servers for your website, okay, and with those four servers you have decided to serve your website. It is built on all the four servers, and you're trying to serve people. But how do these requests hitting to your website understand that they should go to all these four servers? All right, if it goes to only one particular server, though you have four servers, when all the requests are routing to only one particular server, then there is no sense in it. Automatically even that server will also go down, and there is no sense in having four servers to reach out all the requirement. In order to come out of this situation, we have a mechanism in our cloud here, that's load balancer. So what do you mean by load balancer? Load is what do you mean by load actually? The load is nothing but what? The request hitting to your website. Okay, or there is some data, and that data is provided a share with, and that can be accessed by people. When many people try accessing that data at a time, automatically it happens the same with the server in which the data is sitting. It's not only website, anything that you are sharing over internet and that is accessed by people, when many people access at a time, that many people accessing is nothing but so much of load hitting to your server. So when load increases more than what it can bear, automatically the server will become unreachable, unresponsive. So in that situation, we'll say the site is down or the data is not accessible, something like that. So to overcome that, we extend our number of servers and to reach out or to distribute all the load. Okay, there should be some mechanism that the load or the number of requests hitting to your website or your data should be distributed to all the servers you have. So that is what load balancer does. So what do? We take a load balancer, we keep it in the front, okay, we keep it in the front, and behind that load balancer we keep all of our servers attached to that load balancer. Then what load balancer does, whenever requests are hitting to that, it will distribute all the requests to all the healthy available servers. Okay, understand this statement. What load balancer does, load balancer receives all the requests and distributes that load or that request to all the available and healthy instances. What do you mean by available and healthy instances? Available means first how many servers are available in your environment, and next thing, healthy instance is nothing but, of course there is a server, but that's not reachable. When the server itself is not reachable, what is the sense of routing request to that server? Alright. So first, this load balancer always check whether your server is healthy or not, that is reaching or not, reachable or not, it is responsive or not. After once it confirmed by itself that the server is alive and then it is reachable, it's responsive, then it confirmed by itself, the load balancer confirmed by itself, okay, yeah, this server is available to serve the request, then it will send. So how does it check? How does the load balancer check whether the server is healthy or not? Okay, all these concepts are seen in today's class. How do we create a load balancer and how smart it is, what way it works, what way it distribute the load and all will be checked today. Okay, are you ready for that? So what do I do? Initially, I'm not creating any instances, we'll do that later. First I'll go create a load balancer. It's still possible for us to do that without instances also. We can do that later on. So I'm going into the load balancer. Okay. Then in this load balancer, I'm currently not having anything because I do not keep anything. I don't want to pay anything. So I'm just going to create a load balancer. First of all, tell me, are you clear with what load balancer is?
Yes, sir.
Everybody? Or you want me to clarify with an idea, any other examples? Hope everybody is clear with what it is. Okay, fine, thank you. So I'm just going to create a load balancer now. I've clicked on create load balancer. Like how we have understood every single parameter in creating or launching an EC2 instance, we have to understand all these parameters here in this. So first one, define load balancer. We have to give a name to it. Okay. Now what I'll say, my web something load balancer. Some name I've given randomly. Okay, fine. So load balancer, let's understand. What example? Okay. So you have a website. That website may be an e-commerce site. You are trying to sell something. Maybe you have a business. That business, not only having a particular office, but you also have an online store for that. So that online store needs a website. All right. So the website, when you have created, maybe very new, people doesn't know much about it, but later on it has become, the website has become very famous. Okay. Initially when no one knows, or when it is known to only a limited amount of people, you have created that website with one server, for example. Let's understand this way. Okay. Later on when it become famous, your website become famous, it has become, slow to access by people, very slow. People when trying to access, it's not reachable that easily, or it is the people are not able to access your website so simply like how it was initially. Why? It's because the number of people accessing your website has increased. The number of people accessing your website increases automatically due to the huge amount of requests. Your website's server will become unresponsive, because it may not be able to bear so much of huge load. What if you are able to read one textbook today in a day, and if I just provide you some 3 to 4 textbooks at a time, and then ask you to complete reading all of them in a particular day, will you be able to cover it up? That may not be possible, right? That may not be possible to cover 3 to 4 when your capacity is reading only one book in a day. So similarly, whenever you create a website, that site needs a server, and that server will have certain capacity or certain limit to serve. When number of requests increases more than that limit, then automatically it will slow down, or sometimes it may go totally or permanently shut down. So in order to overcome, we increase the number of servers. But what if even after we increase the number of servers, okay, you had only one server initially, and after noticing that your website has become very popular, and you have bought another 2 new servers to serve your purpose. Now you have 3 servers, but all the way these requests are hitting to only one particular server, and the other 2 servers are being idle. So in that situation, what is the purpose of having 3 servers, and there is no solution to your issue with number of servers just increase like that. So we wanted some sort of mechanism which distribute all the requests hitting to your website to all the available servers in your environment. So that's what is done by load balancer. So load balancer balances all the load. Balancing in what way? It will distribute. For example, you have 3 servers, and 6 requests have come. For example, 5 requests have come. Okay, you have 3 servers and 5 requests have come to your website. Then what happens is, first load balancer check whether all the 3 servers are healthy or not. Once if it gets the response that that all the 3 servers are healthy, then whatever the request, 5 requests have come, out of 5, first request will be sent to first server, second request to the second, third request to the third server. It distributes in a round robin way to all the healthy servers, and next fourth request is to the first server, then fifth is to second server. Then since there are only 5 requests, this is how it is distributed. So one after the other, in a round robin way, the distribution is done. So in order to define what is load balancing is, you understand, load balancer distribute all the load or requests hitting to your server will be distributed, okay, equally to all the healthy and available servers in your organization. Okay, all the healthy and available servers. The distribution of load or request hitting to your website or anything, the distribution of that equally to all the available and healthy instances. That's what load balancer. So today we are going to see how that load balancer function, I mean, what way it is created, what way it is just, created. Whenever you create a load balancer, always it is placed in front. Okay. After that, okay, when load balancer is placed in front of that, in front, and all the servers are placed behind the load balancer and connected to the load balancer, attached, all the servers are attached to the load balancer. So when you are requesting something from these servers, it will not go to the servers directly, but it will go to load balancer, and from there the load balancer will send the traffic or allocate a server or route this request to a particular freely available server. So how does it check whether it is healthy or not? How it distributes the load? What way the load balancer is created and placed in front of the servers? All that we are going to check. So for that, what we have to do, we need to log into a management console, AWS management console. After once that is done, okay, you have to go down and you'll find load balancer. After once you found load balancer, you have to click on create load balancer, then you will find the screen which is available now, which is seen for you guys. Okay, does that make sense, Shifa? Yes. Hope you could understand. Yeah, fine, thank you. So now what I'm doing for in the first tab, define load balancer, we have to give a name to that and select a VPC. So since we have separate VPC created, I'm going with the default VPC available, and I've given a load balancer name, my load balancer name as my web load balancer, just like that. Then create an internal load balancer. Yeah, I need to tell you this. The load balancers of two type: internal load balancer and external load balancer. What do you mean by internal and what do you mean by external? Let's try to understand. You have an organization working for, and in that organization, there is a server in which so much of data is uploaded, and that data is to be accessed by your organization employees only, not to the external world. So you have provided a share to all such documents or files or whatever it is. So how does people will be able to access? So you can have a load balancer even for that server also, when all the employees access some data all at a time. All right, it's nothing but you have a finance data, and that server, the finance data is in a particular server. Maybe in the beginning of your month, you have issued all the employees salary statements. So when everybody is trying to access their salary statements, which are placed in one particular server, that salary statements may find some, the server may find difficulty to serve all such employees requests when they are hitting at a time. Similarly, when HR people provide you some link and for some survey and ask you to participate in that survey, and you all have uh, one sec dear. Yeah, sorry for the disturbance. So that needs to be accessed. Even in that situation, you have to provide a share by keeping that survey documents in one particular, server. So anything internally, within the organization, when something needs to be shared, okay, and that if you find that it needs to have a load balancer, then you keep a load balancer in between, in front of all such servers which are needs to be accessed, which are about to access by all your employees. So that is internally within the organization when you wanted to have a load balancer. And then what do you mean by external load balancer? External load balancer is nothing but apart from internal access, you have a website, and that website is open to everybody, entire public, like yahoo.com, flipkart.com or amazon.com, something like that. All right, or google.com, which is open to everybody, entire world. In that case, external load balancer is to be created. So when something is open to world and made to access that by the entire world, then in that situation we go with external load balancer. And by default, when you create a load balancer, it will be an external load balancer unless you just click on this. Okay, unless you click on this box, you check this box, it will be an external load balancer only. All right. So now I'm creating an external load balancer because I'll go create a server and install Apache server into that. Okay, in that instance, then create a web page. That web page I'll try to access by my load balancer. Okay, so for that, the web page is accessed over internet, and for that we need to have an external load balancer. So I'm not creating an internal one, I'm going with an external. Enable advanced VPC configuration, I'm not going with that. Let's keep things as simple as that. And one more thing, the real-time issue, you must have to take port number 80, that's HTTP, because this is an external load balancer, and where people try to access via internet, and when they try to access via internet, they should be allowed to access a website or our data, and that's possibly done by port number 80. So port number 80 should be enabled. So the load balancer protocol, port number 80 should be enabled, and by default it's enabled. And if you wanted any more protocols to be attached or given access with, then you can just go and add here with this button. Are we clear with this tab? Shall we move on to the next one?
Yes, sir.
Yes. Fine. So what we have done in this tab, we have given a name. We have done nothing, but we have given a name. The options, if you have any VPC created, your personal VPC, you can go select that VPC. And there are two type of load balancers, that's internal one and external one. If you wanted an internal load balancer to be created, you just need to check this box. If not, let it be. Let it be as simple as that. And then you can just go with advanced VPC configurations, that's for an additional layer of security, but I'm not going with that. Give me a sec, I'm sorry. Yeah, I'm sorry. So that's which enables advanced VPC configuration. And then listener configuration is this, the load balancer protocol, who needs to listen and how it needs to listen, that load balancer listen all that. So it listens via port number 80 and grant permissions to access your data, because people request over internet, especially when it is an external load balancer. So I'm moving on to the next tab, that's assign security group. Remember, you can have multiple security groups attached to it. I'll tell you one real-time scenario here in this case. Okay. In real-time scenarios, remember, we will never provide the permission or inbound traffic to everybody. Okay. For example, if you take Sydney security group, this is what we have created. If you just take, okay, I hope you remember, I have taken two inbound rules. One is HTTP port number 80 and the other one SSH port number 22. But for both of these port numbers, okay, I have selected source as anywhere so that anybody can access. But in real time, in our organizations, we will never provide access to everybody unless it's a public site. Okay? Unless it is a public site where everybody can access, we do not provide it. We take some custom IP addresses, and in that custom IP addresses we list out who and all can access this data. Okay? So in that custom IP, what happens, there is a new user appointed in your organization, or a new laptop is provided to some employee and his IP address has changed, the range of IP address has changed, for example, and he's not able to access this data. So what do? It is possibly done by going and editing the security group attached to this. Rather, you can also, you edit a security group which is existing. You can also go attach another security group to that with the new persons, or the person's new laptop, whichever the new IP address it is having, provided access to that. So that is why you can have multiple security groups attached to that. So you can select both or select only one. I'm just going with only one. That is one security group. Okay. Or if you wanted to create another one, you can also do that. But I'm not doing that. I'm just going with another existing default security group. So going to the next one. This is one way of having a security to your environment. And if you wanted another additional layer of security, okay, you can just go to this configure security settings. For that you need to have SSL certificates. So load balancer is not using any secure listeners. Your traffic to the load balancer needs to be secure. Use either HTTPS or SSL protocol. So SSL certificates you probably needed. If you have SSL certificates, you attach here. If not, it will be not an issue. We do not needed that compulsorily. This is just an additional layer of security. That's all. Then go back to the next tab. Go to the next tab. And this is what we probably have to understand clearly. Okay, it is kind of configuration stuff. So how do we configure? The first one is HTTP, the ping protocol. How will it ping to the server? Which means I have told you people that the load balancer always check whether the server is healthy or not, whether the instance is healthy or not. How does it check whether the instance is healthy or not? Alright, so to check that, to check whether the instance is healthy or not, this is where we fix that. So port number 80 is the permission provided to that. Over that port number 80, it always ping a particular file, a particular web page created separately. That web page, it will keep on pinging, which is onto a particular server. When it get a proper response from that server, then it will consider, this server is healthy and it is reachable. If it do not get any response from that particular web page created, then it consider that the server is not healthy, and it will keep on hold and stop sending request to that instance. So this is what. And the ping path, what is the ping path? The web page, the web page created on a particular instance, which is always pinged to check whether the server is healthy or not. And here what I'm doing is, I'm not giving index.html, because when somebody is trying to access a website, if not they specify any specific page they try to access, it will by defaultly take them to index page. So the index page is a default page when somebody is trying to access a website. So I don't want it to give the default web page, but I would like to give a separate web page which is accessed by only this load balancer to check whether the server is healthy or not, whether the instance is healthy or not. Rather, I provide a default. So what is that web page I wanted to create? I wanted to create a web page with this name, healthcheck.html. healthcheck.html is the web page I would like to create. I will create, of course, once we launch an instance. So after once that is done, it will keep on pinging to this web page. When this web page responses to the load balancer, then it will consider, okay, this instance is healthy. But how does it ping? Okay, these are the timings provided. You wanted to know what these are? You just place your cursor over this I, you'll understand. So the response timeout, the time to wait when receiving a response from the health check. So first it will send a ping. It will send a request to that healthcheck.html web page. And how long it needs to wait to get the response from that web page? Sometimes, it may be busy in serving another request. So how long it needs to wait? The time provided to that will be 2 seconds to 60 seconds. So it can wait in this period of time. So by default we have provided 5 seconds of time. So it will wait for 5 seconds when once the ping request is sent to that. Within 5 seconds, if it receives any response from that web page healthcheck.html, then it's fine. It validates that request. If not, it will consider failed. The ping response is failed, and then it will consider that instance as a default instance, faulty one. And interval. So what is this interval? Interval is nothing but the time interval between every two consecutive ping responses, pings. So once, for example, the very first minute, okay, very first minute of the first hour or any hour, very first minute, the load balancer has sent a ping response, ping request to particular instance. Okay, waited for 5 seconds and it has received its response. Okay, but sending a ping response to an instance for one time is not enough. Probably it's not enough. It needs to check continuously. So right. So the next ping response, with what time interval it needs to send the next ping response. That's what is defined here. It needs to send another next ping response to the server or to the instance after 30 seconds. So 30 seconds will be little higher for us. What I'll do, I'll just make it 10 seconds. So it will wait a 10 seconds of time, and after 10 seconds it will send another ping request to that instance back. Wait for 5 seconds, get the response, come back, and then after 10 seconds it will send another ping response. So it will keep on pinging that instance after every 10 seconds with a a response time of 5 seconds. You clear with that? Then the next one, unhealthy threshold and healthy threshold. Any doubt? Anybody? You
No,
understood?
sir.
Yeah. Everybody understood what's response timeout and what's time interval?
Yes.
Okay. The next one is unhealthy threshold. What's unhealthy threshold and healthy threshold? Which means, the unhealthy threshold is mentioned to be 2 times and healthy threshold is mentioned to be 10 times. I'll change this to 3 times. So number of times or number of responses it needs to wait for treating a server or an instance to be healthy or to be unhealthy. Okay, if it gets, for example, unhealthy threshold is mentioned 2. So what it does, every 10 seconds it will respond, it will send a request. So for example, for the first second it has sent a request to instance 1. It has got the response after 10 seconds. Okay, it has sent another request. Then the second request did not get any proper response from the instance. It has waited for 5 seconds but still no luck. Then it has considered, okay, this response is failed. After another 10 seconds, okay, it has sent another ping response, and this time also it did not get any response. So for how many consecutive times it did not get the proper response from server? First time it got the response, but for the next 2 times it did not get any response. So what we have mentioned here, number 2 we have mentioned, which means if the server do not respond continuously for 2 times with a time frame of 10 seconds, waiting for 5 seconds every time it requests a ping request, it sends a ping request, okay, it needs to consider, the load balancer consider that the server is unhealthy. That's what unhealthy threshold. The number of times you mention, number of requests it wait for to validate this server is healthy or not. Since it is mentioned 2, it will only check 2 consecutive request ping responses. If it finds any 2 consecutive ping responses are not properly received, okay, not responded to the ping response any instance, then that instance is treated to be unhealthy. So no requests will be sent to that. Then what about, okay, it doesn't mean when the instance is treated unhealthy, it doesn't mean that the instance is, that the server is useless. That may be there may be a number of reasons. There may be some a number of requests sent to that server, and due to those n number of requests the server may be busy, so it could not respond with this ping health check dot html. So that may be a reason. Or due to huge load, it might not respond. So temporarily it is treated to be unhealthy, but not permanently. Then after some time the server comes back to the normal situation. When it comes back to the normal situation, it should be reused again. So how do we able to reuse it again? It's not, isn't it? We should not simply ignore a server just like that. When number of requests increases more and more, and we keep considering our instances unhealthy like this, then end of the day it's of no sense having this load balance. So how does this unhealthy, server made to be a healthy and then able to serve all the requests? That's possibly done by healthy threshold. So 2 times it has checked and did not get response. So for after 2 consecutive times it will consider as unhealthy, but it will not stop pinging to that server. Okay. The moment, of course, it will consider that the server or instance is not healthy, but the load balancer does not stop pinging that server, though it's healthy or unhealthy. And after, once it is treated to be unhealthy, later on, if it get, since I have taken number 3 here, if it get continuously 3 times a proper response from the server, okay, proper response from the server for 3 consecutive times, then that instance will be treated again as a healthy instance, and the load balancer starts sending the distributing the load to that instance as well. So this is how the load balancer is really very smart enough to check which server is healthy and which server is not healthy, whether to send the load to that server or not. Okay, when server is too busy in serving all the requests allocated to that, even after that, if it keep on assigning, if it keep on sending requests to that, then automatically it will fail to reach or serve all such huge amount of requests. So for that, it will give a break to that instance which has huge amount of load allocated. So this is how it works out. unhealthy threshold, consider that instance is not healthy, and then healthy threshold, reconsider that instance is being healthy, and then now can send or route all the traffic to that or distribute load to that. Are you clear with all these points?
Yes, sir.
Yes. So let's move on to the next tab. Add EC2 instances. This is where you need to add instances, and of course it can be, you know, um, you can also do that for later on, because I do not have any, instances currently running now. If you have instances currently running, all those running instances are listed here, so you have to pick what instances are to be, attached to this load balancer. So there are no instances available. When you come down, enable cross zone load balancing. So see, smart enough, this is really smart enough that you have created a instance in one particular, maybe 2A zone or 2B zone or 2C zone. It's not only that, you can have your servers built on multiple locations or multiple availability zones, and still you can have your, website reach out all of them. It's nothing but, if there is some disaster happen in any particular availability zone, your entire infrastructure go down. In that situation, you create servers in all the multiple availability zone, which means all the available data centers, and you wanted to serve people. In that situation, you create a load balancer, and to that load balancer, enabling cross zone load balancing, you attach all the different zones, different availability zones instances to this load balancer. Clear with that? And connection, enable connection draining. It is for 300 seconds, which means 5 minutes. The number of seconds to allow existing traffic to continue flowing. Alright, though it is healthy, you cannot continuously send traffic to a particular instance, right? It needs to send only for 300 seconds. After 300 seconds, it will give a break to that particular instance, so that it can get relief from all the load sent to it, or reach out all the, serve all the requests and come back to normal. So then after 300 seconds, it will be uh, distributed. It will get distributed all the load back to it. So that's what enable connection draining. So both of them are by defaultly checked. So it's fine, fantastic. So that's what we are going to check now. We will be checking, we will be testing that. The next thing is add tags. What do you know? What do you give the tags? You can just give multiple random tags here. For example, your ID you wanted to give. ID would be some number, some randomly providing, and create. What is that? The next one, name of it, or purpose. The team. Which team owns this load balancer? Maybe application team. Something like that. Random. I'm giving something and all. So you can just have multiple tags to a particular load balancer. Then go to the next one. That's lastly review and create. So you can check one last time what and all the configurations you have given, parameters you set. Once you confirm everything is fine, there is nothing to be edited again. You go create the load balancer. Are you clear with this creating load balancer? Everybody, is there any doubt? Say yes or no, please.
Yeah, it's everything is clear.
Fine, price clear, Anu is clear. Yeah.
So is this load balancer charges, like it's free?
It will charge. Okay, it will charge.
Okay, it will charge.
Yeah. So because it distributes the load to all the multiple servers available, right?
Yeah.
It is a mechanism, or it is a service we are utilizing. So even for this service, there is a little minimum amount of charges provided. Fine. Only few people are responding. I wanted everybody to be active in the sessions, please. So fine, our load balancer is this. Okay. Let's try to understand all its tabs. The first one is description. The same description is also seen here horizontally and vertically. When you wanted to see, you come down, and that description you'll have the DNS name. So this is what the DNS name provided to the load balancer. So remember, every load balancer will have a DNS link name, a DNS link allocated to that by defaultly, and nowhere you provide an IP address to that, nothing like that. The running instances are by default listed, and from that list of running instances you have to pick how many number of instances you wanted to attach to this. So nowhere we have come across of public IP address or private IP address. So how do this load balancer be able to communicate with that? So that's possibly done by that instance ID and all which we have attached to that, the load balancer. So to access that website or data, what do? We have to go to this link, my web. That's nothing but the load balancer name, the ID, okay, the ID provided, then the region in which your load balancer is created, then Amazon AWS.com, and this is totally called as a record, alias record. A stands for alias record. Of course, okay, this DNS name, the default DNS name which is provided when a load balancer is created, obviously it's not user friendly because people find difficulty to remember this number, the number. So what do we do? If you wanted to reach your site just like that, you have to register a domain, and that domain will be allocated or attached with this. So then when people try accessing that, so for example results is there, okay, that you wanted to announce results online, so for that you have a domain name registered, onlineresults.com, for example, something like that. So you have to make sure that when people type onlineresults.com, it should directly route that traffic to this load balancer, and from this load balancer it should send it to all the servers you have attached to this. So you have to go register that domain name, and that domain name is allocated or assigned with this domain name, then it will reach the purpose. Because this set of IP addresses associated with the load balancer can change over time, you should never create an A record with a specific IP address. That's why we have never given any IP address, because sometimes when server is not reachable, where you have to stop it and start, its IP address change. So nowhere we talk about IP addresses of instances allocated to or attached to the load balancer. Okay, and when you wanted a friendly DNS name, then we have to go, okay, if you want to use a friendly DNS name for your load balancer, instead of the name generated by Elastic Load Balancing Service, you should create a CNAME. So A record stands for alias record and CNAME stands for canonical name. Alias record and canonical name. Understand this way. The difference is in between alias record and canonical name. Alias record is a DNS name which is defaultly provided to a load balancer. Okay, that's not user friendly. So we go register a proper domain name. That registered domain name which we are going to allocate or assign to the load balancer DNS name is known as canonical name. Sorry. So that's what the difference between alias name and canonical name. You clear with that? I'm sorry. Excuse me for that. Yeah, I'll explain. I do that. Give me a second time. So don't worry, we will also discuss about A record and C name again in Route 53. But for now, understand C name is nothing but canonical name. Canonical name. Okay. There are two uses with this canonical name over alias record. So first understand what is alias record. Alias record, A record is a default DNS name provided when an ELB is created. Okay, the default DNS name, which is not user friendly. Clear? Since it's not user friendly, when you wanted something very easy for people to reach out your site, for that we probably need a domain name created. For example, you wanted to search something in the internet, so what do? By default you go type google.com and then search whatever you wanted in that, because everybody knows that Google is a search engine, a good search engine where most of the people use it. But do you ever think that Google search engine also have a server behind it, and that server will have an IP address? Okay. When people are provided with IP addresses, whenever you stop and start the instance for your maintenance purpose, its IP address change, right? The public IP address by defaultly change, and you cannot have a number of elastic IPs so that you create and allocate to that. There is a limit of a number of IP addresses that a region for an account you have only 5 elastic IPs created. So how is that possible? You wanted a DNS name, and of course that google.com also have so many servers, and so many servers are kept behind a particular load balancer. So that load balancer will also have an A record, and that A record is provided to you, who will keep typing or remembering such a huge lengthy DNS name. Alright, so to overcome that, we have C name option, canonical name option. That canonical name is nothing but you simply register a domain name with some sites, just like godaddy.com or something like that. We will discuss all this stuff again in Route 53. Don't worry. It will be just like a reminder for you then. Okay. So that C name is created and assigned to this, just like google.com I said. So that google.com domain name is allocated or assigned with this default DNS name, that is nothing but A record. Then whenever people search something by going into google.com site, the moment they say google.com enter, it will defaultly come to the requests are sent to this ELB over this A record, and from this A record it will go provoke all the servers or distribute the data or load to all the servers available. So that's what CNAME and A record. I hope that makes sense for you. Alright. And these load balancers are only cross availability zonal. Within the region you have n number of availability zones, and your environment is created in those n number of availability zones when it needs to reach. But when it needs to have across the regions, your website is built and needs to serve across the regions. So how do you allocate this load balance to work with across the region? So we don't have that option of creating a load balancer to send traffic to all the servers across the regions. We have across the availability zones, but across the regions we do not have. So how is that possible? You select the other region, create number of servers over there of similar softwares. That's possibly done by creating an AAM and copying it to that respective location. From there you create instances with the respective AMI. Okay, and these multiple zonal, not sorry, multiple regions. These multiple regions load balancers, when needed to be reached simultaneously, because both these multiple regions load balancers have got similar sort of servers which have our website built on them. So how do they access when the environment is set up in cross regions? Which means that's possible by CNAME, canonical name. How is that possible? In this CNAME, whatever the domain name you register, that registered domain name can be allocated to multiple multiple availability zones and multiple regions. That is the use of CNAME. Are you clear with that CNAME? Canonical name? Yes?
Yes.
Okay. Okay, fine. The next, internet facing, that is nothing but external world to the world. It's not internal, external it is. Then all the details whatever we have provided are seen. Those are availability zones. Cross zone load balancing we have enabled. You wanted to disable, you can disable it here. So like that, all the configurational stuff is mentioned over there. The next, instances, this is where you can add your instances later on. So we still don't have any running instances, we ourselves have to create and attach to them. Then health check. This is what we have seen, how it needs to send traffic to that responding. Monitoring, every single service will have a default monitoring for 5 minutes, and if you wanted a detailed monitoring, you have to select here so that the default monitoring is available and you can have the data set by monitoring all the environment, how healthy your servers and all. So what and all it monitors? The 9 parameters it monitors basically. Then next, security. What security groups you are attached to that? Business. Then tags. So these are the tags we have provided to our load balancer. So that is what all about load balancer. Are you clear with creating a load balancer and how do we access that? You clear? If you are clear, then we will be testing this load balancer. Okay, guys, for today I would like to take a break with this. I have a call to be attended or addressed in a short time. So if you are okay, for today we'll stop a session with this, how to create a load balancer, and tomorrow I'll probably show you. Initially, first we'll see how load balancer work by creating instances, and if you are interested you can do this, create instances, multiple instances in all the availability zones. After creating instances in all the availability zones, I'll show you this tomorrow anyhow, not to worry. I'm sorry for stopping the class all of a sudden. So install Apache server into that, create two web pages. One is healthcheck.html, which we have provided, through which a load balancer can ping each and every time and then confirm whether that server is healthy or not. And another index page, index.html page, that is how you can access over internet. But all these pages, web pages, are to be created where? In the root directory of the Apache server, that's where www.html, and then see how you are able to access these files. You clear with that?
Yeah.
Yeah. Hope there is no doubt. Is there any doubt? Is there anything you wanted to clarify? Yes?
On this, nothing, sir.
Okay, done. Thank you. And yeah, we do have class tomorrow. Only Sundays in India we will not have a class. And Saturday is an optional. Tomorrow we'll have a class because I'm just leaving little early.
Okay.
Yeah, but see, check
Sir, like,
if you're interested, check how it works, load balancer works with the information I have provided. If not, just try creating a load balancer and stop. Yeah, I'll certainly do that. I'm sorry I did not share the video yesterday, but today I'll surely try sharing the video. If not, my internet connection works out, I'll just try to upload these files, these videos using my mobile network only. Okay, so
sir, can we create VPCs?
we will do that. Yes, we will do that. When you wanted to frame an entire organization in this public cloud, how do you isolate your own organization? Because everybody can log in, everybody who have created an account can create a number of organizations into that for different projects. Organizations in the sense a number of infrastructures or data centers. So
Okay.
there should be some security that no one should access our organization or our infrastructure. So for that we have to build VPC. That is how we isolate our resources. And we will see that creating a VPC, we will see, definitely we will see under networking part. Okay, we are in EC2. Once EC2 is done, EC2 probably by Monday I'll try to finish it up. Tomorrow we are meeting, and after tomorrow Sunday we do not meet. Monday, tomorrow we may start auto scaling or may not, because there are few things I need to discuss before I start auto scaling. So Monday we'll try to finish auto scaling, and I hope probably we'll finish our EC2 by Monday. Then go to storage, then go back to our database. Then when you finish database also, then we have VPC here. So this is where you go create your VPC.
Sir, generally, like in real time, once we launching the server, what kind of work we do in the server, sir?
What kind of?
Work, I mean, what kind of work we do in the servers once we launch the
See,
server?
being a cloud engineer, you need not to know what you have to do with this server. People come to you and ask
Okay.
for creating a number of servers for their need based on the requirement they have. So depending on that requirement, taking that requirement, you will just create servers and provide it to them.
Okay, so our job is just to create servers, that's it.
Yeah. Of course, if you have Linux idea, that is what I'm saying. At least the basic idea of Linux, if you have, fine. If not, the last session I'll discuss something about what is that I'm talking?
Linux.
Yeah. So instances and all.
Okay.
So we will certainly see that. How do we connect? And for that, we need to know how we have to handle these servers. If it is a Windows server, we need to know what is how we operate Windows. If it is a Linux OS, we need to know Linux to play with those servers.
Okay.
Okay, so we will check that. Not to worry. And every single thing, whatever I'm doing, I'll explain. If you have any doubt, you can ask me anytime and then clarify your things. And about A record and C name, we will discuss again in this topic, Route 53, because this is domain naming service. So how do we associate the DNS name of the alias record with a C name? Okay, the registered domain name. That's done here in Route 53 topic. Okay. So for now, I'm going to stop a session. So I will delete this load balancer. Now I'm done. I'll recreate it tomorrow. That doesn't take so much of time because today we had to understand all those things, so it's taken time, but not fine. Are you clear with these things, dear? If yes, I'll stop for today's session. Meet you tomorrow. If it is possible, okay, if it is possible, can you please join tomorrow's class probably by 6:30, 7 o'clock IST in the morning? Is that possible to you?
Yeah, no
Everybody?
problem, sir. But
Yeah. Probably by,
yeah, for me, no problem.
yeah.
Like already two of them are left.
Okay. Who's left?
Already two of the people left, so we should ask them to.
Okay. However, we have a WhatsApp
Anu
group,
and
right?
Shilpa has left.
Okay. Okay. However, we have a WhatsApp group, right? So
Yeah.
I'll communicate in that. So let's drop all your inputs. Based on that, we'll meet tomorrow,
Okay.
whatever the time it is possible. Because my shift is ending at 6:30 IST, and I'm waiting for about an hour
Okay.
for you guys. In that 1 hour time, I am sometime taking some time a little nap. That's making me to log in little late. So rather I wait for you guys, wait for about an hour in between. Tomorrow if it is possible, we'll try to meet little early and then check. I have taken 1 hour of break in between. If in case if there is any issue I need to address, then it may prolong. That's why I have taken an hour of break in between. But I don't think there will be an issue tomorrow. So that is what
Okay.
I'll test. I'll be in touch
Sir.
with you guys. If there is no issue, however, I'll
Okay.
communicate in the WhatsApp. So if there is no issue, we'll meet up by 6:30 in the morning IST times. Okay?
Okay.
Fine, then catch you tomorrow. See you.
Yeah. Sir, one more thing. Like, is this a middle level? No.
Oh, come on. What is that? Come again, please.
Middle level
Your voice is breaking, Sai. I don't know why.
Okay. Is Amazon Web Service is a middle level programming?
Middle level programming you're talking about.
Yeah.
See, this is not,
Like, is the Amazon Web Service a tool or what?
it's not tool. It's not tool. It is a service. Okay? It is not a tool. A tool is always installed. Alright. Linux is a tool
Okay.
you have to install.
Okay.
And all the applications which we install in our computer are tools. But this is nowhere we have installed
Okay.
anything. We have created an account and we are utilizing it. So it is a service rather a tool.
Okay.
Clear? It's a cloud service, especially,
Yeah. Okay,
to
sir.
be precise.
Okay.
Fine then.
Okay.
Okay then. See you.